Now in this part we'll talk about the linear momentum as a conservation of linear momentum. This is part 3. وهون رح نحكي بالضبط عن collision and especially the elastic collision. So when do we say that the linear momentum is conserved? We know that summation of external is equal to dp over dt, and this is what we found in the last part. So شو معناتها isolated system? When I talk about an isolated system, this means that the summation of the external forces is equals to 0. So شو معناتها summation of external forces is equal to 0? This means by substitution نحن بنعرف إنه summation of external forces is equal to dp over dt. So if I substitute, we'll have dp over dt is equal to 0. So when I say the derivative is equal to 0, and the question is the conservation of the linear momentum, then this means I must reach P, which is called the linear momentum. So by antiderivative, the antiderivative of 0 dt will be a constant. So هيك بنلاحظ إنه an isolated system where the summation of external is equal to 0, then the linear momentum is always equal to constant, and this is what we call the conservation of linear momentum. Now, during a collision or explosion, these external forces are neglected with respect to the internal forces. So this is why we say that the system can be treated as an isolated system. This means that the linear momentum is also conserved. So always in the case of a collision, during the collision, the linear momentum is conserved. Now, if I want to trace a figure here, so in the case of a collision, if this is the object A and this is the object B, and at the instant during the collision, we have the forces acting on A and B are the weight of A, weight of B, normal of B, and normal of A. We also have the force done by A on B and the force done by B on A. Now these are all the forces on A and on B. But if I took, for example, a system in the case of collision, when I take the system is A and B together, then the external forces, what are the external forces? We see that summation of F external is equals to what? Is equals to WA plus WB, the weights, plus normal A plus normal B. But I can't add here the forces FA on B and FB on A. ليه؟ لأنه these forces now صاروا هنا عبارة عن internal forces. It's done by A on B. And A and B are both in the system. So this is why these are internal forces. Now إذا بيجي بعمل projection on the x-axis, on the axis of motion, we will have that the summation of F external is equals to 0, which means رجعنا وين? In the case of summation is equals to 0, this means that P is constant, the linear momentum is constant. So this is why I can say that any collision or an explosion, always the linear momentum is conserved. Now, if I want to talk about it, so I can write it like this. هيطلع لنا the answer. Just so هيك بيطلع عنا that P before, when I say P is constant, this means that P before the collision is equals to P after the collision. Now, when I say that it's an elastic collision, not only collision, elastic, كلمة elastic collision بتدلني that the kinetic energy is also conserved. This means that KE before is equals to KE after. So KE before the collision is equals to KE after the collision. Let's do now an application. Now, here you have the red ball, which is chasing after the blue ball. They have their respective masses M1 and M2, and the speed of the red ball is V1, whereas the speed of the blue ball is V2 equal to meter per second. Knowing that the collision is elastic. First قلنا collision, second قلنا elastic. So this means بمجرد ما نحن عرفنا إنه collision, okay, I don't have to verify if it wasn't asked to verify, okay? I can directly say that collision, this means that the linear momentum is conserved. This means P before the collision is equals to P after the collision. Now, when I say P before is equal to P after, we have both. We have two balls. And when I say it's elastic, this means I can write it like this. So if it's elastic, this means that KE before the collision is equals to KE after the collision. Now أصعب سؤال ممكن يجي إنه يكون كله الشغل without values يعني كله عم بيشتغل in terms of. So بهالحالة you have steps. First the question is what? Determine the speed of each ball after collision. Of each ball this means V prime 1 and V prime 2. We have two unknowns. لما يكون عندي اثنين unknown يعني we must have two equations. So هي هون. This is the first equation and this is the second equation. Now بمجرد ما عرفنا الconcept then we can continue the calculation. كيف يعني? Now here when I say P before is equals to P after then I can write it. This means P1 plus P2 is equals to P prime 1 plus P prime 2. This means after the collision. So we'll have here نعمل substitution. We'll have M1 V1 vector plus M2 V2 vector is equals to M1 V prime 1 vector plus M2 V prime 2 vector. And then هلا هو كله in terms of vector, but we must pay attention that we are using collinear. أنا عم بشتغل هون as collinear speed, collinear velocity. This means صار في يقول له هون the velocities are collinear. Since they are collinear velocities, this means I can take off the vector. So بيطلع عندي algebraic value. This means V1 M1 V1 plus M2 V2 is equals to M1 V prime 1 plus M2 V prime 2. And then شو بنعمل? Then in this case I take a common factor. So باخد M1 as common factor. We will have V1 بجيب هيدي لهون حيطلع عندي minus V prime 1 and it's equals to M2. We'll have, sorry, here it's V prime 2. So it's V prime 2 minus V2. And this will be our first equation. From where? From our first condition, which is the collision. Now the second condition will give us the second equation. So when I say KE before is equals to KE after, this means I will write in this form. So KE, this means it's half M1 V1 square plus half M2 V2 square, which is equals to كمان half M1 V prime 1 square plus half V2 prime square. We can take off all the half, simplify. كمان we can take a common factor. So إذا جينا أخذنا M1 common factor حيطلع عندي M1 V square V1 square minus M1 V prime square is equals to باخد هون common factor. So حيطلع عندي V prime square 2 minus V2 square. And then شو بيجي بعمل هلا؟ صار في أخذها in the form of A square minus B square. So حيطلع عندي A minus B A plus B. So we'll have as answer M1 V1 minus V prime 1 and then V1 plus V prime 1, which is equals to M2 V prime 2 minus V2 and bracket V prime 2 plus V2. And here, this is our second equation. This is 2. So now شو بنجي بنعمل? This is our first, this is our second equation. Now we'll do the system of these equation. كيف نعمل هلا system? Now the step number 3 is to divide. So this is step number 3. We divide equation 2 by equation 1. So when I divide these two equations, we will have here, okay, so رح فينا نعمل simplify by M1 and M1 and then V1 minus V prime 1. From this side M2 and M2 and then V prime 2 minus V2 and here. So بيبقى في عنا from the division V1 implies V1 plus V prime 1 is equals to V prime 2 plus V2. and then شو بنرجع نكمل هلا then هلا فينا نيجي ناخد نقول that this means v prime 1 is equal to v prime 2 plus v2 minus v1. So here I will continue. So we'll have so we'll have here v prime 1 is equals to بنلاحظ هيا v prime 1 is equal to v prime 2 plus v2 v prime 2 plus v2 and minus v1. هيدا وين بنرجع بنحطها؟ شو بنرجع بنعمل now? And then now we do a substitution. So minus v1. This equation, we substitute this equation in the equation number 1. Equation number 1 اللي شو طلعت معنا؟ طلعت معنا m1 v1 minus v prime 1 equals to m2 v prime 2 minus v2. So when I substitute this v prime 1 here, هيطلع عنا only one unknown. يعني we'll have now m1 between a bracket v1 minus v prime 2 minus v2 and plus v1 equals to m2 v prime 2 minus m2 v2. So عملت expand here. Now بكل الأحوال لما بدي اجي اكمل calculation, this is v1 plus v1, so it's 2v1. So حيطلع عنا here, I will continue this part. So حيطلع عنا here, it's 2m1 v1 and then minus m1 v prime 2 and minus m1 v2, which is equals to m2 v prime 2 minus m2 v2. Now بقى عنا one unknown. مين هي is v prime 2. So صار في أخذها as common factor and I will have m1 plus m2 between a bracket v prime 2 is equals to all this part, which is 2m1 v1 minus m1 v2 and here plus m2 v2 plus m2 v2. So at the end we'll have v prime 2 is equals to all this part over m1 plus m2. So حيطلع عندي 2m1 v1 minus m1 v2. هلا فينا ناخذها كمان factor هي كمان لل v2 إذا بدنا نظبط الشكل. Okay, this is m. كلها it's over m1 plus m2. Now after doing this, this is who? This is v prime 2. شو صار فيي أعمل هلأ؟ صار فيي إجي أخدها لهيدي ال v prime 2 أعمل لها substitution here. لما بعمل لها substitution here we'll have v prime 1. هيك بنكون طلعنا v prime 2 and v prime 1 in terms of m1 v1 m2 v2. So هي هون. This is the answer. Okay, هذا اللي حطلع لنا الانسر هي هون. كتب لكم إياه. Same thing إذا بيطلع v prime 1 لما بدي أعمل substitution رح يطلع عندنا هيدا الانسر. Now, if the question is to calculate the values when the balls have equal masses, okay, when they have equal masses, this means m1 is equals to m2. So if m1 equal to m2, so I will do a substitution and then I حط ال v1 وال v2 بقيمتهم كvalues. We'll have as answer v prime 1 and v prime 2. So بقي ما تبقى aside just only a calculation.